All right, let's talk about nth terms since we are kind of struggling with this. And the nth term is basically a geometric or algebraic sequence. It's a recursive pattern, recursive meaning it repeats the same pattern, uses the same rule over and over to figure out the next term. Oftentimes it's using the previous term. Our algebraic is the one we started way long ago. There are two different ones that you could see. So the way you could see it would be something like a sub n here, okay? And what we're using is a1, which is going to be the first term. And we get there because we multiply it by what we change, our rate, and then we use this as the n minus 1, so that's going to be the previous term. So we're using the term before. So that n minus 1 gets you, when you multiply it by that rate, gets you to the first term. Okay, so a1, if you notice here, this a sub 1 goes along with the n minus 1. Okay. The other one that we've done in the past, this is the way we've worked it in the past, is to get to a sub n. We've used a sub 0, which is the zero term, the one that doesn't really exist in our sequence, but we back it up, and then we just take r times n. Notice that it is going to be the 0 goes along with, there's just an n there. It's not anything going on there. So some examples. I want to come up with a formula. We have -4, 2, 8, 14. So every time it looks like we are adding 6. Every time. Okay? So it's a consistent recursive pattern. So if I want a sub n, one way is I can use this first term. So -4 plus my pattern is 6, and I'm going to have n minus 1. Okay, and it's not to the power because this isn't geometric, it's just n minus 1. The other option, I could have a sub n, and what I can do is I can go back 1 to find my 0 term. So if I subtract another 6, I would have -10. So I could be at -10 plus 6, and this time we're just going to use n instead. Either one of those is acceptable, okay? You could see them either way on worksheets, answer choices, whatever, so you need to realize that they are the same. If I were to distribute on this top one and simplify, I am going to get that bottom one right there. So the second example, it says, given a sub n is 6 minus 2 times n minus 1, find the first 4 terms. Well, here's the thing. As soon as I see this n minus 1 right here, I know that this is my first term. And to show that, I could do the following. I could say, okay, well, n minus 1, if I'm finding a sub 1, I'm going to have 6 minus 2 times 1 minus 1. Well, 1 minus 1 is just 0, and 2 times 0 is just 0. So 6 minus 0 is going to be just 6. So again, we're back to that. Now to find the next one, a sub 2, I'm taking 6 minus 2 times 2 minus 1. Well, 2 minus 1 is 1. 1 times 2 is 2. 6 minus 2 gives me 4, which basically tells me right here, no, wrong one. This rate right here, and since it's a minus 2, we're going down 2 every time, and that is what's happening. So that means this next one, a sub 3, if I plug that in, I should end up with 2. So 6 minus 2 times 3 minus 1, well, 3 minus 1 is 2. 2 times 2 is 4. 6 minus 4 is 2. So yes, it works. So this other one, I really don't even need to plug it in. I know that I should end up with 0. Okay, and that would happen when I plugged in a 4. 4 minus 1 is 3. 3 times 2 is 6. 6 minus 6 is 0. All right, so there's our algebraic. All right, let's look at geometric. So geometric is a recursive pattern using a multiplier. So it's times instead of, so we're multiplying instead of adding something repetitively. So again, it's the same type of thing, only they look just a little bit different. So a sub n, we have that going on here. And so what I notice is first term n minus 1. So it's to the power this time, but it's still the first term n minus 1. So first term, and then we use that n minus 1, and it's to the power this time. So for this second one, when we have that going on here, so a sub n for this one we are seeing a sub 0. And when we do that, we're just using to the n. And I know that doesn't quite look like an n. It kind of looks like an r, but it really is an n. So I'm going to actually maybe just add that little extra little bit there. See, it's to the n power. Okay, so it's the same type of thing, but instead of adding, we are multiplying and using a power. We're using the previous term is what that n minus 1 means. So find the formula. Here we have, so I'm down to some examples. 4, 8, 16, 32. And hopefully I'm noticing that I am multiplying by 2 every time. So multiplying by 2, and so on. So if I use my formula to figure this out, a sub n is going to be, if I use my first term, I have 4 times my rate is 2, and I'm going to say to the n minus 1 because I'm using that first term. The other option would be to have a sub n, but I can go back 1, so I would end up dividing by 2, and 4 divided by 2 would be 2. So I could use a 2 here times the 2 as well, because the rate stays the same, and it would just be to the n power instead. They're both the same thing. As soon as we take those, it works out to be the exact same value, whether you start with the first term or that term beforehand. Okay. So given a sub n equals negative 2 times 3 to the n minus 1, find a sub 5. So one of the things that I noticed is that this is going to be my first term. So that's a sub 1 because I'm using this n minus 1. All right, so a sub 5, that means I'm going to plug in 5 where n is. So I've got negative 2 times 3 to the 5 minus 1 power. Well, 5 minus 1 is 4. And so I'm basically taking 3 to the 4th power, okay? And 3 to the 4th power ends up being 81. So we end up with 3 to the 4th, which is 81 here. And I still have the 2 out front. So 2 times 81 ends up being that 162. So a to the 5th, or not a to the 5th, a sub 5, sorry, the 5th term is going to be 162. Okay? And then finally, this last example, it says a to the first, or a sub 1 is 11. So that's my very first term. A sub n is 2a, and then sub n minus 1. Find the first 4 terms. I kind of ran out of room over there. Okay, now this is weird. This is not to the power of n minus 1. So what in the world is this saying? Well, if I take a look, a sub n is my current 1. A sub n minus 1 is the previous term. So we're looking to find the next term. So whatever our next term is, whatever it is, we're going to use the previous term. Okay? So that's what that is saying. So a sub 1 took the previous term, multiplied it by 2 to get 11. Okay? So we have the first term of a sub 1 is 11. If I need a sub 2, I'm going to take 2 times, well, a sub n minus 1 would be a sub 1, because 2 minus 1 is 1, and we know that's 11. So really, this is just 2 times 11, which is 22. So a sub 2 is 22. A sub 3, I'm going to take 2 times a sub 2 now because it's the previous term. And so I'm really going to take 2 times 22, so that's going to be 44. And then a sub 4, we're taking 2 times the previous term, which is the a sub 3, and so really I'm taking 2 times 44, which is going to be 88. Hopefully these have helped enough that you can finish up that worksheet. That worksheet will be due. So take care of that. Come see me. We can hopefully work through some other stuff.